Hey everyone, and welcome back to AI Paper Podcasts, where we do deep dives into the latest and greatest AI research papers. Today we're going to be looking at something pretty fascinating. It's all about how AI can learn to get better at problem solving over time. Kind of like how we humans get better at things with practice. The paper is called Cognitive Behaviors That Enable Self-Improving Reasoners.
Oh, this is a cool one. I'm excited to dig into this. It's really interesting because it's not just about training AI models to perform certain tasks, but it's looking at how they can actually improve during the problem-solving process itself.
Yeah, exactly. It's almost like giving AI the ability to kind of learn on the fly, becoming more efficient and more effective as they go.
Right. So the researchers actually looked at something called test time inference. It's essentially that period when the AI is actively working on a problem, and they wanted to see how some AI models can actually use this time to learn and get better through reinforcement learning, or RL.
So it's not just about all that pre-training beforehand. It's about enabling the AI to actually learn from its own experiences in real time.
Yeah, exactly. And they did this by pitting two different language models, Qwen and Llama, against each other in a game of Countdown. You familiar with that game?
Oh yeah, I love Countdown. It's like that mental math game where you have to use numbers and arithmetic to reach a target number, right?
Precisely. So they basically set up this AI Math Showdown. And here's where it gets really interesting. They found that Qwen, when paired with reinforcement learning, just became amazing at it, like a total math whiz. But Llama, on the other hand, even with the same resources, didn't really improve that much.
It's almost like Qwen had some secret weapon that Llama was missing, right?
That's a great way to put it, and that's exactly what the researchers wanted to figure out. What they discovered was that Qwen's success really boiled down to 4 specific cognitive behaviors that it was naturally employing during the game.
Okay, so these are like mental strategies, things that we humans use to solve problems.
You got it. Think of it as like the AI's mental toolkit for problem solving. And the 4 key behaviors that they identified were verification, which is like double checking your work, backtracking, realizing you took a wrong turn and got to try a new approach, subgoal setting, breaking down a complex problem into smaller pieces, and backward chaining, where you kind of work backward from the desired outcome to figure out the steps to get there.
These all sound like incredibly useful skills, not just for math, but for anything, really.
Yeah, absolutely. And when they looked at Qwen's problem-solving process, they found it was just naturally using these behaviors, especially verification and backtracking, which seemed to be really key to its improvement.
So Qwen was like a natural at using these mental strategies, but Llama was kind of fumbling around.
It's a good analogy. So the researchers wanted to see if they could prime Llama to use these behaviors, give it a crash course in effective problem solving.
So essentially try to level the playing field and give Llama the same mental tools that Qwen seemed to have already.
Exactly. They created these special training data sets that specifically demonstrated these 4 cognitive behaviors, and they used those data sets to train Llama.
And what happened? Did Llama suddenly become a math superstar?
You bet. Once Llama was primed with these data sets, its performance with reinforcement learning just skyrocketed. It started matching Qwen's performance, showing that it could really improve its puzzle-solving ability.
That's incredible. So by simply exposing Llama to these cognitive behaviors, they were able to unlock its potential for self-improvement.
Yeah, it really seems that way. And it gets even more interesting because then they took it a step further and actually primed Llama with data sets containing incorrect solutions.
Wait, so they train it with wrong answers? Why would they do that?
I know it sounds kind of counterintuitive, right? But the thinking was actually pretty brilliant. They wanted to see if it was the process of reasoning rather than just getting the right answer that was driving the improvement. So even though the final answers were wrong, these incorrect solutions still showed those 4 key cognitive behaviors.
So it's like they were teaching Llama how to think like a good problem solver, even if it stumbled along the way.
Precisely. And guess what? Even with these incorrect examples, Llama still showed improvement. It really suggests that it's those cognitive processes themselves that are crucial for reinforcement learning to be effective, not just achieving the correct outcome.
Wow, that's a pretty profound insight. It means we might not need perfect examples to teach AI how to reason, but actually imperfect examples could be even more valuable as long as they showcase those good problem-solving strategies.
And this opens up all sorts of exciting possibilities for AI training. Imagine being able to use a much wider range of data, including examples where the AI might initially make mistakes to actually help it develop more flexible reasoning skills.
That's fascinating stuff. So we've seen that these cognitive behaviors can make a huge difference. But how practical is this for real-world applications? Can we actually engineer this self-improvement ability into AI systems?
Yeah, that's the million-dollar question, right? And that's exactly what the researchers wanted to explore next.
So they wanted to see if they could make AI inherently predisposed to learning and improving right from the get-go.
Exactly. And to do this, they turned to pre-training data. They looked at these massive data sets that are specifically designed for mathematical reasoning. These are like open web math and fine math. Think of them as the AI equivalent of textbooks and practice problems.
Okay, so they were checking if these textbooks were actually teaching the AI those right problem-solving skills, those 4 cognitive behaviors we've been talking about.
And here's where things took another surprising turn. What they found was, even in these math-focused data sets, the cognitive behaviors were actually pretty rare.
So even the textbooks weren't teaching the how of problem solving.
That's right. They were more focused on the what, like the concepts and formulas, but not the process of how to apply them. It kind of highlights a blind spot maybe in our traditional AI training approaches.
It's like we've been missing a key ingredient all along.
Well, that's what this research seems to suggest. So to address this gap, they decided to create a new pre-training data set, one that was specifically enriched with those cognitive behaviors. They took text from Open Web Math and used this powerful language model, Qwen 2.532b, to actually rewrite it in a way that clearly demonstrated those reasoning patterns.
It's like they created a new and improved textbook one that actually teaches the process of problem solving, not just the raw information.
I like that analogy. And the results were pretty remarkable. After training Llama on this new behavior-enriched data set, it finally started showing the same level of self-improvement as Qwen during reinforcement learning.
That's amazing. So by actually incorporating these cognitive behaviors into the pre-training data, they were able to kind of hardwire these skills into the AI's foundation.
Exactly. And this is huge because it suggests that we can actually make AI inherently more likely to learn and improve without needing those specialized priming techniques every time.
This could be a total game changer for how we approach AI development in the future.
Absolutely. We're not just talking about training AI to solve specific problems. It's about giving them the tools to become lifelong learners, capable of adapting to new challenges and coming up with innovative solutions that maybe we humans haven't even thought of yet.
This has been incredibly fascinating so far. We've seen how these cognitive behaviors can truly unlock some serious potential for AI to learn and adapt. And we've even explored how researchers are working to bake these behaviors into the very foundation of AI systems.
And that's really just the tip of the iceberg. In the next part of our discussion, we're going to delve even deeper into the nitty-gritty of how the researchers measured those cognitive behaviors and the techniques they used.
We'll also tackle some of the bigger questions this research raises, like what other kinds of thinking skills might be important for AI to master different tasks, and what happens when AI goes beyond imitating us and starts to develop its own unique ways of thinking.
It's going to get even more mind-blowing, so make sure you tune in for part 2 of our deep dive.
See you there.
Okay, so let's dive a bit deeper into how the researchers actually conducted these experiments and what they found.
Yeah, because saying AI showed cognitive behaviors sounds impressive, but how do you actually measure something like that? You can't just ask the AI, hey, are you verifying your work right now? Right?
Exactly. We can't just get a little report from the AI about its thoughts. The researchers had to get a bit creative here. They focused on the actual text that these language models were generating as they solved the countdown puzzles. It's kind of like analyzing the AI's thought bubble as it works through the problem.
So, like they were looking at the AI's version of showing its work. Like how a math teacher would want to see all the steps, not just the final answer.
Precisely. They trained a separate AI model, G2 Mini, which is known for being pretty good at understanding and analyzing text, to identify specific patterns within those problem-solving steps.
Wait, so it's like AI analyzing AI. That's pretty meta.
Yeah, in a way. They basically taught GPT-4 Mini what each of those 4 cognitive behaviors would look like in the context of solving a countdown problem. So, verification, backtracking, subgoal setting, and backward chaining. They gave it clear examples and trained it to spot those patterns in the text generated by Qwen and Llama.
Okay, so can you give us a specific example? Like, what would verification look like in the AI's output?
Sure. Imagine the AI is trying to reach the target number 32. It might say something like, okay, I'm going to check if 8 times 4 equals 32. Yep, that's right. that explicit checking step, that's verification.
So it's not just the math itself, but the language the AI uses to express its thought process.
Exactly. Those little linguistic clues give us a peek into how the AI is approaching the problem, what strategies it's using.
That's really cool. It's like we're starting to see into the mind of the AI a little bit, seeing how it reasons and makes decisions and even corrects itself.
Now, remember how we talked about priming Llama with those special training data sets? Well, creating those data sets was a whole project in itself.
Yeah, they didn't just appear out of thin air, did they?
Not at all. They used another powerful language model called Claude 3.5 Sonnet, which is really good at following instructions and generating text. It's like a super-powered writing assistant.
So they basically told Claude to solve countdown problems while demonstrating specific cognitive behaviors.
Exactly. They'd give Claude very specific instructions like, solve this problem, but make sure you use backtracking. And don't use any other fancy techniques, just stick to backtracking.
That's clever. So they were basically training Claude to be a cognitive behavior actor for Llama to learn from.
Yeah, you could say that. And they didn't stop there. They actually created 5 different data sets, each with a unique combination of behaviors. So one data set focused only on backtracking, another combined backtracking with verification, and so on.
So that way they could really isolate the impact of each behavior and see which ones were the most important for Llama's improvement.
Precisely. And remember, those data sets with the incorrect solutions, those were important too. By having Claude demonstrate the right reasoning process, even if it got the wrong answer, they could really test if it was the behaviors themselves that mattered rather than just getting the right answer.
Okay, yeah, that makes sense. Now, you also mentioned these control data sets, the empty chain of thought and the one with the placeholder tokens. What was the point of those again?
Right. Those were important to make sure that any improvement they saw in Llama wasn't just because it had more processing power, but because of the specific cognitive behaviors it was exposed to. You see, when you prime a language model with more text, it essentially has more thinking time to work with.
Oh, I see. So they had to make sure that the improvement wasn't just from having more time, but specifically from those cognitive behaviors.
Exactly. They needed to isolate the effect of the behaviors themselves. And the results were pretty clear. When they primed Llama with those empty or placeholder data sets, it didn't really improve that much, even though it had more thinking time. This tells us that it was really the cognitive behaviors, not just the extra processing power, that made the difference.
That's a really important distinction. It really highlights how important it is to teach AI how to think more effectively, rather than just giving it more compute power.
Absolutely. Now, going back to that finding about priming Llama with incorrect solutions, the fact that Llama still improved as long as those solutions followed the right reasoning patterns, that was pretty remarkable.
It's almost like learning from mistakes is more valuable than just being told the right answer.
Well, think about it. Even when we make mistakes, the process of figuring out where we went wrong and trying a different approach, that's super valuable for learning, right?
Yeah, totally. So it's like the AI is internalizing those problem-solving strategies even if the final answer is wrong. It's learning the logic behind the process.
Exactly. And that opens up some really interesting possibilities because it suggests we might not need perfect examples to teach AI how to reason. We can leverage imperfect examples as long as they show those good reasoning patterns.
Yeah, that could be a real game changer for AI training.
All right, so we've seen that these cognitive behaviors can have a big impact on self-improvement in this math game. But you might be wondering, can we make this happen without having to use these specially primed data sets all the time?
Yeah, that was my next question. It would be awesome if we could somehow build this self-improvement ability directly into the AI models themselves.
Absolutely. Priming is a great way to test these ideas, but it's not the most practical thing for real-world applications. Ideally, we want AI systems that are naturally inclined to learn and improve on their own from the start, right?
That's right. So did the researchers find a way to do that?
They did. They took a closer look at the pre-training data. Remember those massive math-focused data sets we talked about? Open Web Math and Fine Math. They used the powerful Quen 2.532b model to analyze the text and see how often those 4 cognitive behaviors were actually present in the data.
So they were basically double-checking the textbooks to see if they were actually teaching the AI the right problem-solving skills.
Exactly. And what they found is a bit surprising. Even in these math-focused data sets, those crucial cognitive behaviors were surprisingly rare.
So even the textbooks weren't doing a good job of teaching the how of problem-solving.
That's right. They were more focused on the what, like the formulas and concepts, but not so much on the process of actually using them. It really points to a potential blind spot in the way we've traditionally been training AI.
Wow, so it's like we've been missing this key ingredient all along.
That's what this research suggests. So to fix this, they decided to create a new, improved pre-training data set that was specifically enriched with those cognitive behaviors. They took the text from Open Web Math and again used Qwend 2.532b to rewrite it in a way that clearly showed those reasoning patterns.
So it's like they created a brand new textbook that actually teaches you how to solve problems step by step, not just gives you the formulas.
Yeah, that's a good way to put it. And the results were really promising. After training Llama on this new behavior-enriched data set, it finally started showing the same level of self-improvement as Qwend did during reinforcement learning.
That's awesome. So by building these cognitive behaviors into the pre-training data, they were basically able to make those skills part of the AI's core.
Exactly. And this is a huge deal because it suggests that we can actually make AI inherently more likely to learn and improve on its own without needing to use those special priming tricks every time.
This could totally change how we develop AI in the future.
It really could. We're not just talking about training AI to do a specific task. We're talking about giving it the tools to become a lifelong learner. You know, something that can adapt to new situations and maybe even come up with new solutions that we haven't even thought of.
This has been a really fascinating look at the world of self-improving AI. We've seen how important those cognitive behaviors are for an AI's ability to learn and adapt, and now we've seen how researchers are working to incorporate those behaviors into the very foundation of AI systems.
And we're just scratching the surface here. In the last part of our conversation, we'll take a step back and look at the bigger picture of what this research means. We'll tackle some big questions like what other thinking skills might be important for AI to be good at different things, and what happens when AI starts developing its own ways of thinking that go beyond what we humans do.
Yeah, that's going to be interesting. So stay tuned, because it's going to get even more mind-blowing in part 3. Okay, so we've seen how these 4 cognitive behaviors, verification, backtracking, subgoal setting, and backward chaining, can really amp up AI's ability to learn and improve, at least when it comes to tackling math problems.
Yeah, it's like equipping them with this mental toolkit to become way more efficient and strategic when they're solving problems.
But it makes you think, what other thinking skills could be important for AI to be really good at other things, not just math?
Oh, that's a great question, and it's something researchers are definitely digging into right now. Imagine AI that can craft these amazing stories or compose beautiful music or design really innovative products. What cognitive behaviors would be essential for those types of creative tasks?
It's kind of mind-blowing to think about, like, what would the AI version of artistic inspiration or creative problem solving look like when we're talking about these cognitive behaviors?
Exactly. We might be talking about things like exploring different perspectives, experimenting with different styles, or even just embracing randomness and making unexpected connections.
So it's not just about pure logic and reasoning, but also about intuition and thinking outside the box.
Right. We might need to broaden our definition of what cognitive behaviors actually are to include a wider range of mental processes, even the ones we usually associate with creativity and innovation.
This research really changes how we think about AI development. It's not just about feeding data to AI, it's about teaching it how to think.
And that leads to another really interesting question. What happens when AI moves beyond just copying our cognitive behaviors and starts to develop its own ways of thinking?
That's where things get really exciting and maybe a little bit unsettling. What if AI ends up finding cognitive processes that are way more efficient or even more creative than anything we've ever come up with?
It's a crazy thought. What if they find shortcuts or strategies that we've just completely missed because of our own limitations?
It would be like AI becoming this ultimate cognitive explorer, charting these unknown territories of thought, and maybe even changing our whole understanding of what intelligence is.
It brings up these deep questions about consciousness, the limits of our own thinking, and how our relationship with AI will evolve in the future.
This research has been eye-opening. It shows the potential of AI, not just as a tool, but as a collaborator, a partner in creating things, and maybe even a source of inspiration for us.
It's a future full of possibilities, and we're really just starting to explore it.
This has been an incredible deep dive into the world of self-improving AI. We've learned how these cognitive behaviors can unlock so much potential for AI to learn, adapt, and maybe even show a little bit of genius.
And we've touched on the mind-blowing possibilities of AI creating its own cognitive paths, maybe even blurring the lines between human and artificial intelligence.
If you're as fascinated by this research as we are, definitely check out the original paper, Cognitive Behaviors that Enable Self-Improving Reasoners. It's a really thought-provoking read.
And if you have any thoughts, questions, anything you want to share, drop them in the comments below. We'd love to hear your take on all of this and keep this conversation going.
Thanks for joining us on AI Paper Podcasts. Until next time, keep those brains buzzing and stay curious.